Welcome to the build video for the basic airframe and electronics installation of the Alight Aeronautics Flik, a sub 250 gram flying wing drone created in collaboration with RC Test Flight. Depending on when you watch this video, the airframes are already en route to us from the manufacturer, or you have one right in front of you and you are ready to get started. Either way, we are extremely grateful for your support in getting the project to this point. We hope you enjoy your Flik wings as much as we do ours, and with that, let's get started. All right, so when assembling the airframe, there's a couple things we can do right off the bat. One thing we will be using throughout the entirety of this build is these little T-pins. They're about an inch long, and they're very helpful for holding everything in place while the glue dries. In this case, I'm using E6000. E6000 is kind of like a rubberized cement. You can use plumbing goop, marine goop. You can use, I don't know, there's a couple other options out there. I usually use Goop, but in this case I'm using E6000. The reason for the T-pins is this takes a little while to cure, so you need everything to be held in place while this cures. Because this is rubberized, it won't let go in a crash. It will flex with the airframe, and so the flexural modality of all these components is similar, thus making a stronger airframe. So we have a groove here, a main groove here in the bottom of the spar slot for the spar. So I'll run a very tiny bead. I just want to put a little bit in the bottom of the spar slot. The reason being, when I push the spar in, I don't want a lot of it to squirt out the sides and then make it a poor fit for the spar covers. So I'm keeping the spar a little bit forward in the slot until we're ready to insert the entire thing, and then I just roll it back into the track that has the glue in it. That way we don't get glue in places we don't want it. And if you zoom in close, you can see there's a little bit of extra glue on the spar. I'm going to wipe off as much of it as I can. And that's just going to make this cover fit a whole lot better if we remove this extra glue. So I'm going to take these pins and I'm going to run one over the spar at an angle. And then I'm going to trap that spar in there by coming back at it from the other side with another pin. I'll repeat that 3 or 4 times down the spar. So I keep working on this now that these pins are holding the spar in place. We're going to put in these Elevon reinforcements along with control horns. Since the two slot together, they need to go in at the same time. So again, we'll do the same process. Gonna run a tiny bead down the slot. And this one will overfill no matter what you do. The slot is just too small not to overfill. Put a little extra where the control horn goes through. And then I can actually drop the control horn down from the top, and I'll go through the, push it through the bottom. And then I run the reinforcement through the little tiny hole that is in the control horn. And then I push it all flush. And you may find that you need to pin it. You may find that you don't need to pin it. As long as I'm not disturbing this actually stays put pretty well. So I'm not going to pin this one and put extra holes in the airframe that I don't need. Same process, control horn comes in through the top. Actually, let's run a bead along the top for me so it seals when I push it in. Because I forgot to reinforce the top of the control horn on the other side. Let's do that now with the popsicle stick. Run a little E6000 right along that edge. Just give it a little more stability. And the last thing we can do while we're at it is the mounting plate that goes on the airframe. We can pop that in place, and then we will set this aside for about an hour or two while everything sets up a little bit more firmly so that we can move on to the rest of the build. and it's gonna go on in an X pattern, not a cross. It's gonna go in the X. And then so that doesn't slide down due to gravity, we'll just prop this up against the wall and let that cure. All right, so to put the canopy together, you'll need these 3 tabs and this rear latch. It's very simple. You'll see a indentation on the canopy for each of these. So I'll just put a little bubble right there. Press that on firmly till glue squeezes out the side. And put a little glue along the opening for the latch, and run a bead all the way down to the end. And then this inserts through the latch. Wipe off any extra off the latch. All right, and these little holes, they lighten up the print. These will be CNC carbon parts in yours. Right now we're just using 3D printed ones. But the latch will be 3D printed. It's a little bit difficult to CNC, so we have some lightning holes in there, but those also are a place for the glue to go in, lock in, and hold that more securely. And then I will just set that aside and let that cure for a couple of hours. It is just glue holding these tabs on, so you want to make sure that that bond sets up really nice. You don't disturb it before that bond is complete. All right, so that's just about ready. These are the spar covers, so let's separate that from the little bridge in the middle. Using an Xacto knife. It wasn't perfect, let's make it perfect. You don't want any extra foam on there because then it won't seat completely. All right, now, because there is a little bit of extra glue that got squeezed out despite me trying to be careful, there's not a lot of extra room. You can see this little spar channel that goes over the top of the spar. I'm gonna make a little bit of extra room so I can get this fully seated and not mess up the aerodynamics. So I'm gonna take some 80 grit sandpaper and I'm going to enlarge that channel somewhat to make room for the glue that got squeezed out. It's a little bit of extra work. I think you will be very happy you did it though. So before we put on the spar covers, for one, I just want to check to make sure it's going to seat fully after I sanded it. We're a little raised on the back end there. I'm going to fix that. All right, good. Now, before I put the spar covers on, I need to get the servos in because I probably won't be able to fish the wire through. Once the spar covers are in place, you will want to center your control horn on the servo before you insert it. It will be hard to put the control horn on the servo and center it after the servo is already in place. So you can use your receiver through your radio, or you can use a servo centering device, a standalone device, whatever you prefer. On this airplane, the control horn is towards the rear. And I'm going to put a little bit of E6000 in there. And I'm gonna make sure I don't put enough in such that when I push the servo in, it gets squeezed into the control horn and the servo horn and locks it up. Okay, so I'm gonna put some here on the back wall. And put some E6000 on the side wall. And put some on this wall back here. And then I'm gonna put just a little bead right there in the bottom to hold it in place, but that won't be enough such that it's going to squeeze out and lock up my servo horn. And I'm just checking down in there to make sure none's squeezed out. We're good. Hold some pressure on it for a few seconds to squeeze out everything. And that's perfectly flush. It's great. And then one dab right there in the middle. So for those of you that are not using the electronics that come with the kit, you're using your own. These are Emax digital servos, 5-gram servos, and they run on 5 to 6 volts. They are not 2S capable, which would be more like 8 volts. So you will need to run that on a BEC. All right, so you're gonna wanna move quickly so that the glue does not evaporate as you're putting these on. If it starts to evaporate and get tacky or set up, it may not compress and allow this to seat all the way in the cavity that's made for it, and that's just gonna kind of mess up the airflow as the airplane flies. Not a big deal, but here we go. Put it on the sidewalls first, and just move fairly quickly. And then I'm gonna run a bead right over the spar itself. All right, and there is a left and a right, so make sure that you get that correct. All right, that is seating very nicely. I am going to hold these in place with pins while that cures. Make your own judgment call. It just puts in little tiny pinholes, but because this is like a rubberized foam, it's not really self-sealing, but it's sort of self-sealing, or self-healing, I should say. So you'll probably never notice the holes after you take out the pins, but that's a judgment call on your part. I was using larger pins at one point. They were like 2 inches long and had a much bigger diameter, and you could definitely see where the pins had been. So when I tried these much smaller pins, that problem went away. All right. And if I just run my finger front to back, I cannot feel the spar cover. And that is what we're going for. Oh, I can feel it right there. So we're gonna put a pin in there. I push down on the spar cover, drive the pin through, and now I cannot feel the spar cover. Cool. Let's do the other side. Don't lock up your servo. And then I'm gonna run it down the spar itself. So if the spar cover is sitting proud at all, I push down with my thumb on the spar cover and then run the pin in right behind it, such that the pin is holding the spar cover down as the glue cures. And then when you pull the pins out, the spar cover will stay where it was pinned. Very nice. Okay, now on to the top of the fuselage. Again, we need to cut out the bridge. I am not going to cut out the bridge for every one of you before we ship this. You will have to do that yourself. I apologize. I don't apologize. All right, let's get off any excess. All right, test fit. All right, looking good. So I'm gonna run one bead on the vertical wall, and then I'm gonna come back and run one bead on the flat parts. And then we'll pin it while it cures. And when you put this on, just make sure you don't pinch the servo wires or the servo leads in there anywhere. And just get the top perfectly flush with the bottom. Again, I prefer the security of the pins in there to hold everything in place so that it doesn't shift while it's curing. And notice I'm driving them at angles into each other so that it can't shift side to side or come out vertically. Same thing along the sides. I'm not going to drive it in vertically. I'm going to kind of come in at an angle. All right, so now we can let that set up. Next, we're going to put on the winglets. Instead of pins for putting on the winglets, we're going to use hot glue. So I'm going to start with the E6000 and I'm going to put on 3 dabs on the wingtip. Do not put it on the elevon itself. And I'm gonna leave spaces for 2 dabs of hot glue. I'm gonna put on the hot glue second because it's gonna start cooling down quicker than the E6000 will start curing. And as soon as the carbon hits it, it's really gonna set pretty fast. So here we go. Probably hold that for about 30 seconds, maybe not even that long. Cools down pretty quickly once the winglet hits the hot glue. All right, did I get that perfectly 90 degrees this time? Better. There's some extra E6000 on there, just rolling it so it rubs off. Nice. All right. That's that. So one other thing we're gonna do before we set this aside to cure, before putting in the rest of the electronics, like the receiver and the motor and speed control and stuff. This is just a roll of 1.5 wide or maybe 40 millimeter wide Velcro that I got at Home Depot, and that's how I'm gonna secure the battery. In this particular case, I'm using a 2S lithium-ion battery, 18650, and I've already, with E6000, put on a strip of Velcro there. So I'm gonna want to strip about the length of the battery, but I definitely don't need it that wide. It's just extra weight, so I'm gonna cut that in half. So that's gonna hold it into the floor of the airplane, but I also need something to wrap around the battery itself so the battery doesn't fly out and just rely on that Velcro alone. So I'm gonna wrap this around the battery to see how long a piece I need. Give that a cut. Again, far too wide. We don't need nearly that much Velcro. Cut that right down the middle. And that's good enough for 2 planes. Go buy another Flik. All right, so again, I'm gonna use hot glue here. I'm gonna kind of form like a cross. The shorter piece is gonna go over the top of the longer piece. The shorter piece is the piece that's gonna hold the battery in the floor of the airplane. Using hot glue again, I'm going to start with the E6000, and I will run a strip of E6000 down each side of the Velcro. And then a bead of hot glue down the middle. And the hot glue is going to hold it in place while the E6000 sets up and really gives it its strength. And that's about where you're gonna put it. Now, if you have a really small battery, the battery is gonna go further forward. If you have a very large battery, it's gonna go further back. You're gonna have to work out all the room the way that you need it. For instance, on my planes with the 2S battery here, I'm putting the autopilot right in there, so I'm just making sure that I'm leaving enough space behind the battery for an autopilot. And the foam, unlike the winglet, is not going to cool down the hot glue very quickly, so I'm going to have to hold this in place a lot longer for the hot glue to cool down and keep everything in place than I did on the winglets. Probably more like a minute. All right, so now we can set this plane aside for about an hour, and then we'll get back to finishing up the basic electronics install. So let's get the pins out of the airplane now that everything has been given time to set up. All right, so given the way that the motor wires exit the motor at an angle, I can't just flush mount this on the back of the airplane. So I'm gonna take my Dremel here and just carve out a little bit of a divot on the top of the motor plate. That's that. You can also see I've taken out a little bit on the plate that goes on the motor itself previously. All right, and we cut the motor holes in such a way, in the screw holes for the motor, in the motor plate, such that you can use anything from a 9mm screw hole spacing to 12mm, so much bigger motors. You probably won't want to go that direction, but if you decide you want to, you will have that option. So now with the cutout on the back of the motor mounting plate and the plate that goes on the airplane, the way those wires exit, it fits flush. Okay, so your speed control will come with bullet connectors on it. I've already taken the bullet connectors off this one, and I will cut the bullet connectors off of the motor as well. But if you want to leave those on, that's fine. And I'm just going to fish in all the through the slot here. And that's about where I will seat the speed control. And then you can see I have very little need for motor wires to make it all the way to the speed control. So that's a very lightweight solution. And again, so that I can continue working on this while the E6000 sets up, I will tack this in place with a little bit of hot glue, and that'll give the E6000 time to cure, but allow me to keep handling it. Be very careful not to put on so much that it squeezes into your motor shaft and locks that up. Okay, that's ready to go. And then what else do I need to do? BEC. So on most setups, you're gonna need a battery eliminator circuit. Because the airplane is running on 8.4 volts and all of your electronics are running on around 5 or 6 volts, if you apply the full voltage of this to the rest of your electronics, there's a good chance they will fry. Again, depending on your setup. I definitely have run setups where everything can run on 2S and I don't even need, or it can run on 8.4 volts and I don't even need this. But most of you will need something like that, either on your autopilot board or as a separate standalone unit. All right, so as you could see in that last frame, we had way too much wire on this BEC for such a small project, so I've directly soldered this into the extra lead that's going to be coming out of your ESC for providing power for just this purpose. So this goes to your battery with the XT30, and this will power all of your 5-volt electronics off the BEC. I'm going to just shorten these motor wires here, chop off these bullet connectors. And you can obviously do this beforehand, before you even put on your motor, if this is the direction you want to go. Now, depending on whatever prop you have, however you attach these motors, if you directly soldered it on, then your prop may or may not be spinning the right direction. So either just put on a reverse prop. If you have bullet connectors, swap any one of these 2 wires, or if you direct soldered it, just move 1 wire, switch 2 wires, and that'll change the direction of your motor to get the right direction for the propeller. Why don't we go ahead and put in our receiver, and for this I will just use hot glue. Now I'll mount that about like so, let the hot glue cool. And on this particular receiver, the top 2 go to the wing servos. All right, so the receiver is in. I'm gonna tack down the battery eliminator circuit so that that's out of the way. And I will plug that into my receiver to provide power. And then I will put in, this is my throttle, ground, and signal coming off the electronic speed control. And then my elevon servos. Okay, all right. Let's get the radio and fire this up.
Welcome to open switch warning. Manual, flaps 2. Trim center, trim center.
All right, let's see if anything releases the magic smoke. There we go. All right, it's alive. Okay, now that the radio is on and I have all my trim centered so I know the servos as well are centered, now we can go ahead and put in the linkages. So these linkages are going to be a little bit long and we'll need to cut them back and probably rebend them as well. Rebend that S joint because it's just too long. I'm going to take the control linkage, put it in the control horn, and get an idea of where I want the first bend in the S bend to go. Take my magic marker, line it up with the control horn, and I know this actually has the right amount of reflex in it, pretty much where we're starting, where the bottom lines up, the bottom of the elevon lines up with the top of the wing itself. So I don't need to adjust that at all. And then I'm going to put a mark right where the control linkage lines up with the hole on the servo horn. Then I'm going to take my pliers and put in a 90-degree bend after the mark. And then we will put in a bend on this side with another pair of pliers because that's going to hurt my hands. wonder if they have like an S bending machine. They probably do. All right, we have this mark. That's actually not where I'm gonna bend it. I'm gonna bend it slightly in front for the first bend. And you'll see why if you try it the other way first. So now that I have the top bend in, I'm gonna put in the second bend. This creates the little joggle that actually goes through the control horn or the servo horn, and I'm going to cut off the rest. Now we're going to feed this through the bottom servo, the bottom hole on the control horn. And because the hole is not perfectly sized to the wire, it's going to take a little force, and I'm using the pliers to backstop the servo horn. Just go slowly and gently. Now it's through. All right, and now the linkage has threads on the end of it, and so you can precisely tune it to the right amount of reflex. And that is too much reflex right there, so I'm going to lengthen the control rod. Let's make sure the airplane is on.
Telemetry recovered.
Just having the servo powered keeps the servo centered as long as your trims are centered. And that is the right amount of reflex. So now we do the other side and we'll pick up there. We still need to put on the prop. Make sure you don't put on your prop backwards. There is a front and a back, so make sure the front is pointing towards the front. And then with the propeller screws provided, secure the propeller on the motor. If, for whatever reason, you are not flying with a camera in the nose, which we have a cutout for, you can take one of these plugs and put it in the nose to keep the aerodynamics clean. That is what the plug is for, in case you were wondering. And of course, you can take a razor and carve it to match the profile. Last step is put on the canopy and go fly. Now, you will notice in this case, I just have my antenna hanging out the breeze, nothing is securing it. Sometimes when I'm flying just a regular RC plane on something like this, I just put a little slit in the wall of the fuselage, and then I just run the antenna through there to secure it.
Receiver still connected. Switch warning. Trim center. Trim center.
All right, before you fly, you will want to make sure that when you hit the throttle, the propeller is pushing the airplane forward instead of pulling it backwards. You'll want to make sure that when you try to go right, the right elevon will come up and the left elevon will go down, and vice versa. When you want to go up, both elevons will come up, and when you want to go down, both elevons will go down. Now, what are good throws on the elevons for a first flight? You will want about 3 millimeters of up travel, 3 millimeters of down travel, and you will want 3 millimeters of roll travel on each side as well. 3 millimeters up, 3 millimeters down. So it's the exact same for pitch as it is for roll. All right, so let's see what we're at right now. Right now I'm getting about 5 millimeters of travel. So on my particular radio, I'm just gonna reduce the throws until we have about 3 millimeters. So I'm gonna bring that down to about 60–65% on elevator, and the same on roll. And there is about 3 millimeters of travel. That's what 3 millimeters of travel is gonna look like. So it's not a whole lot, and that's going to be it for our first flight. As you get used to the airplane, you may find you want more travel, and also a lot of you, probably most of you, if not all of you, are going to have an autopilot in the mix, and so that actually won't be relevant. There are bumps on the bottom of these airframes. They're a little bit hard to see, but you can see one right here. There's one on each wing, okay? And for a first flight, I would actually recommend going about 4 to 5 millimeters in front of that mark, okay? That's gonna make your plane a little bit less efficient. You will notice there are dimples on the bottom of the wing on the left and right, and that's where it's a rather aggressive center of gravity position is. When you have the aircraft well tuned, that is where I would fly it at, but when you're just doing your first flight, I would actually move it 4 to 5 millimeters in front of that with the throws that I just gave you. That's going to be a very medium setup. It's not going to be too docile, but it's not going to be too aggressive. As you get used to the airplane, you can move the center of gravity back to those dots, and if you have an autopilot in the mix, you can probably just start at those dots, but that's up to you. Anyways, that's what building the Flik entails. Have fun. So I promised my cameraman Chris a long time ago a Flik wing, and then I damaged one of the initial Flik wings, and then I took back the Flik wing that I gave him. So now he gets his very own Flik wing that we built in real time. He didn't know this was coming, but here you go, Chris. You finally got your plane back.
Thank you.
There you go.